Sorry. It's a beautiful day here in central Pennsylvania, so I hope it is wherever you are. Today, we are looking at 596A peer review presentations. We have a interesting lineup of 4 papers that we'll hear throughout the duration of our time together. Each presenter will have 30 minutes for both the presentation and questions. And when the presentation is done, check out the chat window for questions from the audience. Make sure that when you respond to the question that you speak the question first so that we can record the question and then the response. All right. So I think that takes care of all the logistics. First up, Samantha Magici is going to present to us on developing a species distribution model of wild lupine for Karner blue habitat restoration. So Samantha, whenever you're ready.
All right, thank you, and good morning. My name is Samantha. Thank you for being here today for my presentation on developing a species distribution model of wild lupin for Karner blue habitat restoration. I've had a personal interest in the Karner blue butterfly since an internship with the U.S. Forest Service provided me with the opportunity to assist in population counts one summer, and ever since then, I've been eager to apply GIS to further explore the species. Moving into some background information for you. The Karner blue butterfly is named for where it was first observed, Karner, New York. The Karner blue butterfly is a federally endangered species, appearing on the list in 1992. And Michigan is home to one of the larger populations where it is listed as a threatened species within the state. Outside of Michigan, Karner blues are also found in Ohio, Wisconsin, New York, and New Hampshire. The endangered status of the Karner is attributed to habitat loss, most significantly due to land clearance for development and the suppression of wildfires. The Karner's lifespan is pretty brief, ranging from a few days to a few weeks. They experience 2 breeding cycles each summer, one in June and another in August. The emerging adults in June lay eggs that are dormant until August, and the August adults will lay eggs that will remain dormant throughout winter until they hatch in June. Karner eggs lay dormant on the leaves of wild lupin, and during the caterpillar stage, these caterpillars feed exclusively on lupin. Growing best in sandy and well-drained soils, wild lupin is a flowering perennial that prefers open savanna or oak barrens. Wild lupin is often outcompeted for sunlight by larger vegetation, and this is why lupin requires natural disturbance such as wildfires to clear the canopy. And being that lupin is the only source of food for a Karner caterpillar and breeding site, maintaining lupin habitat is imperative to the Karner survival as well. And one way these species are being preserved is with habitat restoration. Habitat restoration has been found to accelerate species recovery and can be achieved using multiple methods. The most popular methods being mitigation, the legally mandated effort to remedy the loss of a species or ecosystem; remediation, which is the improvement or creation of an ecosystem that has been disturbed; revegetation is to reestablish lost vegetation at a site or increasing site suitability with habitat enhancement. Habitat restoration efforts have been successful in revitalizing other endangered disturbance-dependent butterflies. Artificial dams and tree removal were used to mimic the natural disturbances of beaver and wildfires necessary for the St. Francis satyr. And with these efforts, the endangered population of the satyr increased each year following the habitat restoration. Selective logging was done to remove overcast trees to restore the habitat and reintroduce the baton blue butterfly. And as a result, the population doubled. So habitat restoration is a useful tool in preserving biodiversity. However, efforts can be costly and should be well planned out and considerate of where success may most likely be. And due to the relationship the Karner has with wild lupin, the successful restoration of habitat for the Karner relies on where lupin is and its potential over time. Fortunately, new statistical approaches enable the prediction of species distribution, helping to establish where lupin may be found. A species distribution model, or SDM, is a depiction of a species' potential range using data points of a species observation in the environmental variables that determine habitat suitability. The result is a predicted distribution derived from where a species is known to occur and the various variables that influence where a species can occur. Species distribution models demonstrate a statistical relationship between a species and limiting factors, specifically abiotic factors. There are many different uses of species distribution models, the most notable being species management, habitat restoration, and looking at the impacts of climate change on a species. And not only can an SDM help to establish where there may be wild lupin, but it can also help to predict the effects of climate change over time using future projections of limiting environmental variables. And the importance of projecting future lupin distribution within consideration to climate change is that it will help concentrate funds, resources, and efforts where restoration may be more sustainable over time. And there are multiple ways of models to generate an SDM. Some include presence and absent data, while others only utilize presence data. And the use of presence-only methods has increased over time due to an increase in available presence-only data in the form of citizen science, such is the case with wild lupin. So to aid in the recovery of the Karner, I ask, where in the state of Michigan are lupin habitat restoration projects most likely to be successful now and in the future? To maintain Michigan Karner populations, a state species distribution of lupin needs to be established for present day and future projected climate conditions. To do this, the maximum entropy methods will be applied in the form of ArcGIS Pro's presence-only prediction tool. Moving into methods. One such model used to create an SDM is maximum entropy, often referred to as MaxEnt. Maximum entropy is a presence-only model that produces a geographic probability of presence. MaxEnt finds the probable distribution of maximum entropy on a cell-by-cell basis, statistically relating limiting factors to a species location to estimate a species' probability of distribution. And entropy is a measure of uncertainty. So maximum entropy is the highest level of uncertainty. And the reason they utilize the highest level of uncertainty is so that it ensures nothing is assumed in the model. And MaxEnt was developed by Stephen Phillips in 2006 with museum species collections in mind. Museum specimens are often tagged with the location where the organism was collected. And seeing that these collections span back many years, Phillips developed MaxEnt to create a historical species map using presence-only data. Located in the Spatial Statistics Toolbox, the presence-only prediction tool utilizes the principles of maximum entropy. The input required by the tool includes data points of known presence locations in the form of a shapefile, and data depicting explanatory variables in the form of rasters or vector fields, or even the distance measured between two features. And lastly, it requires a defined study area boundary. Study areas can be defined three ways. The first being the smallest polygon to encompass all of the data points, which is known as the convex hull. The extent of all the rasters intersected, or with a vector feature class. And for this study, a vector feature class depicting the Michigan border will be used and obtained from the state of Michigan's GIS portal. It is depicted here. The presence data will be obtained from the Global Biodiversity Information Facility, or GBIF. GBIF is an international citizen science organization dedicated to making biodiversity data accessible across the world. GBIF is a regulated and quality-controlled databank of over 100 million species data points. It's a government-funded initiative, and it provides easily accessible data to anyone, anywhere. All you have to do is create an account. The data obtained from GBIF is provided in the form of a CSV file containing coordinates. So to prep this data, these coordinates will be used to generate a point file. Bioclimatic variables of temperature and precipitation will be obtained from WorldClim, both present and future data sets. Future climate data is available from WorldClim in 20-year increments out to the year 2100. The future data sets that will be used here will be from 2041 to 2060, 2061 to 2080, and 2081 to 2100. The elevation data will be obtained through USGS provided by NASA, and the elevation raster will be used to extract the slope and aspect across the state. And the soil data will be obtained from the United Nations database, and tree canopy cover, or TCC, will be obtained from NASA as well. A shapefile of Michigan's state land will be obtained from Michigan's GIS portal, and this is to focus efforts on public land rather than private land. And the rasters will be sampled to the same resolution as the WorldClim dataset. Now, running the tool initiates a whole series of steps. First being spatial thinning as applied to the species observed data points. Spatial thinning is the use of a defined nearest neighbor distance to dictate how close two data points can be by reducing the number of data points within the defined distance specified by the user. And things to consider when specifying this distance is the species itself. So lupin is pretty clustered. So we'll keep the defined nearest neighbor distance relatively small. And the purpose of this is to limit sampling bias or duplicate observations, which is a common problem encountered when using open citizen science data. And next, background points are generated where need be if indicated. Some data sets may already contain background points, wherein this step is not necessary. But these background points are used to capture data at unreported or unknown locations to compare to the observed data at known presence locations. The tool then extracts values from the explanatory variable data sets, and these extracted values are used as X to plot against Y being the probability of presence. Various transformations can be applied to these XY pairings, and these include linear, pairwise, or squared. And the tool then minimizes coefficients using regression analysis to identify and remove statistically insignificant variables from the model and providing information on the more statistically significant variables. And validating itself, the tool resamples points randomly. Finally, the probability of presence is predicted. The generated results will consist of what's called an output predictor raster, and this will be the SDM depicting the probability of presence. And in addition to this, the resulting rasters and charts generated during those intermediate steps will be generated too. And this includes the training rasters created during the resampling to train the model, and a table of the variables as plotted against X against the probability of presence being Y, which is generated during the data extraction, as well as diagnostics. I anticipate restoration efforts to be limited due to a decrease in potential area just with changing climate trends in general. And I expect most potential areas to be located in the northern lower peninsula. And this is based off personal and geographic understanding of the state. The southern half of the lower peninsula is heavily populated and contains the major metropolitan areas in the state. And the upper peninsula contains dense forest, which I suspect will limit lupin. I expect the most significant variables to be canopy cover and soil type because lupin needs specifically sandy soils that are well drained and requires open canopy so it's not competing against others for sunlight. I intend to prep my data in January, run my analysis in February, create my maps, tables, graphics in March, compile my findings into a paper April, and prepare my presentation in May so that I can present my findings in June at the Imagine 31st Annual Conference. Imagine, which will take place at Crystal Mountain, Michigan. Imagine is Michigan's GIS Professional Association, and the acronym stands for Improving Michigan's Access to Geographic Information Networks. And yeah, with that, I'd like to open this up to questions.
All right, thanks, Samantha. That was a great presentation.
Thank you.
As we wait for some questions to pop up in the chat, I have a couple of thoughts for you. One, I noticed that you had mentioned that you were looking at soil surveys from the United Nations. I'm not sure at what scale. I'm not familiar with those soil surveys, but and I'm not sure exactly what scale you're looking at for spatial resolution. But are you familiar with the Surgo and StatsGo soil surveys that are provided by the Soil Service?
I don't believe so. Can you repeat that for me?
So there's StatsGo and Surgo, SSURGO, and the StatsGo is at 1 to 250,000. Surgo is at a scale between it's compiled between 1 to 12,000 and 1 to 360,000. So it would give you, I think, especially with the Surgo, a more detailed soil sample analysis, if you will, for Michigan than probably what the United Nations would give you.
Okay, thank you.
I can give you in the chat. I'll private chat a message with you on the links to those soil databases.
Oh, yes, please. That would be much appreciated.
Yeah. And then I guess another question kind of unique to Michigan is the fact that it's two separate large land masses. And yet you're treating Michigan as I guess a whole. So how does that factor in any way with the way the model computes and then how you would analyze those results?
Not specifically, because the model is set by whatever boundary you give it. And the reason that I did the whole state of Michigan is because just from my experience, like when I was with the Forest Service, the restoration like looked at the whole state of Michigan, even though it realistically didn't apply to the whole state, like not everywhere. And I really don't anticipate the UP to contain that much area. So it is something to consider. Like I might between now and then condense it down to the Lower Peninsula.
Yeah, I just didn't know. I'm not a lupine expert. So you would know better than I would the potential distribution, and I didn't know if including two separate land masses would affect the way that the model would analyze and ultimately give you results. So just something to think about. That's all.
Absolutely, thank you.
Looks like you have a question in the chat.
I hadn't been familiar with gbif.org. How much are you able to rely on or use data from there? I'll have to explore it more. So GBIF is actually a combination of another conservation. Oh, iNaturalist. So if you're familiar with iNaturalist, those observations go through GBIF as well. And like I said, it is a regulated website. So there have been many studies in forming this proposal. There's been so many studies that have relied on GBIF. So I, in turn, am taking it as a trusted source. That being said, though, you do have the opportunity, because it is a citizen science website, of having duplicate reports of data. So that is definitely one thing to consider when using it. Sounds great. Yep, absolutely recommend. There's so much data on so many species on there. Is there a minimum presence probability that you'd be looking for to set aside an area for preservation?
Hi, this is Jim. I'm sorry. Let me see if I can clarify what I'm trying to ask here. Um, I missed your first minute or two, so I may have missed this, but I'm assuming that what you're hoping to do is to, with your final layer that predicts the probability that of presence, that I'm guessing that your hope would be that you could find places that have a high probability and then do some sort of preservation efforts there to improve the likelihood that the present that the plant will grow there. Is that right?
Yes, that is
So
correct.
so I guess my question is there some sort of threshold for, this is where we want to target? Is it 80%? Is it 60%? That's what I'm getting at.
Okay. Yeah, there will be. I'll be honest, I haven't hammered that out quite yet, because it also has to take into consideration how much these variable, like which variable is the predominantly, what is the word I'm looking for? Which variables are more significant.
Mhm.
So yeah, that'll have to be hammered out further.
Okay.
Which there is an option to weight the variables, which is something I might explore once I run it a few times, which would absolutely change what would be considered minimum presence probability.
Yeah, you may want to tinker with the weightings to see what sort of difference you get in your results too,
Hmm.
to see how sensitive it is to different weights.
Definitely.
All right, any other questions for Samantha? If not, Samantha, if you could put your contact info in the chat window. If no one has a follow-up question, they can use that to contact you.
Alrighty.
All right. So next up, we have Christina Purcell.
Okay, can I go ahead and share?
Oh, yes, please do. Sorry. All right, we see your presentation.
Okay. Should I give a few minutes or should I go ahead and start?
Yeah, go ahead and start. That'd be fine.
Okay. All right. Hello, everyone. My name is Christina Prussel, and my capstone project is titled Raining Cats or Dogs, Comparing Data from Multiple Precipitation Observation Methods. And I've had the pleasure of working with Dr. Guido Cervone as my faculty advisor on this project. So I'll start by giving some background context of the project and its related topics, and then we'll move on to some previous studies. Then I'll discuss the goals and research objectives that were guiding this project. Next, we'll talk about the study area, data sources and methodology. And then to wrap up, I'll talk about my timeline and presentation location, along with some anticipated results. So why do we care about rain? Well, if we think about it, the hydrologic cycle is the very lifeblood of our universe. We literally wouldn't be alive on this beautiful planet if we didn't have rain. And it turns out that measuring that rain is important and applicable to many different disciplines. And some of those examples would be agriculture. Farmers need to know how much rain that we've received so that they know how much additional water resources they may need for their crops to keep them healthy, or maybe even how much less they can be using if they're getting enough natural rainfall. Another example would be meteorological records and operations. Meteorologists use climatology records to initiate numerical weather prediction models, which in turn they use to initiate their forecasts that you and I would use on a daily basis. And lastly would be for emergency management and infrastructure management. So having the measurements would help someone that's trying to figure out where they may need to put a new retention pond in a civilization. And they can also provide real-time inundation information. These measurements contribute to river flood forecasting. And that's very important information for people who need to respond to flooded out areas to maybe rescue some folks. But it turns out getting precise measurements of rainfall is actually a real challenge in the atmospheric sciences. And there's a couple different reasons for this, one of which is the types of instruments that we're using. So if you imagine that we're using a manual rain gauge, if there's a storm event that has a lot of wind involved, not all of the rain is going to make it into the gauge. It may blow over the top of it, and so you're going to get less of amount of measurement than actually has been falling. Another reason is human error. Some of these gauges rely on human observers, and naturally we all make mistakes. And lastly, there's algorithms that come into play. If you think about the Weather Service radars, rainfall amounts are sometimes derived by their reflectivity, and that's produced by complex algorithms, but they may not always be applicable to the locale that you're trying to get the amount for, or perhaps even the season or storm event that you're trying to measure. So moving on, I want to talk about some of the instruments that we do use to measure. There are three main call them methods to measure rain, and that's rain gauges, radar, and satellite remote sensing. This project's only going to focus on gauges and radar, as the satellite products can be pretty spatially and temporally coarse. So the first image on the left here is a manual rain gauge. So it has an inner cylinder that has the little tick marks on it for you to make your measurements. And they do have the big opening on the top, and they range from about 4 to 8 inches in diameter. This type of gauge is used across the National Weather Service. And as I've already mentioned, they do require human observers. So the job of the observer first is to place it in the correct area. Now, what I mean by that is there's guidelines that state they should be unobscured, not elevated, so not on your roof, but they should be protected. So an ideal location would be maybe like an opening in a grove of trees, which I don't know about you, but I don't have that in my backyard. So these can be pretty challenging to place sometimes. But once you do place them, it would be your job to take the measurement at whatever time interval that the observation network you're reporting to would require. So if it's 7 a.m., you got to be awake and out there at 7 a.m. to take the report. And then you would have to empty it and reset it for the next day's observation. The second type of rain gauge in the middle here is called the tipping bucket gauge. These measurements are done automatically, and they're sent by computer, which is very nice. So like the name, there's a little bucket mechanism inside that once it fills up with a certain amount of rain, it'll tip. So that tipping action will tell the computer to add a certain amount of water to the measurement that it is taking. The downside of these is they are very mechanically complex inside, so they're easy to be like out of calibration. So if you're not following a strict maintenance schedule for these, they can be misreporting very slightly for a while before you realize that they need to be recalibrated and repaired. The last image on the right side of this slide is the weather surveillance radar with Doppler. These are part of the next generation radar network that is currently deployed throughout the National Weather Service. They provide the radar imagery that they use on a daily basis. And radars can measure rain in an indirect way. So basically, they show a reflectivity amount. So they're looking at precipitable water in the vertical of the atmosphere. So this is where the algorithms do come into play. Even though there's rain or precipitable water in the atmosphere, it's not a one-to-one with the amount of rain that you're going to see at the surface. So that's what those algorithms are trying to figure out, the relationship between that. But again, they are very complex, and unfortunately, they're not infallible. So now we want to talk about some of the reporting networks of rainfall measurement. So the instruments that we talked about can be collected into different types of networks. For the sake of this project, I'm dividing them up into official networks and citizen scientist networks. So on the left side, I have some images to represent what an official network may be. That top image is called the Automated Surface Observation System, or also known as an ASOS. This is an interesting suite of instruments that are usually located on airfields, and these automatically record data every 5 minutes. So they take variables like precipitation type and amount, wind speed and direction, temperature, pressure, humidity, all that good stuff. The image below that represents the National Weather Service Cooperative Observer Network. And this is a group of spotters that have special training. They all use the same equipment, and they all make their observations every day at 7 a.m. local time. Actually, on the left side of this picture, the little shed-looking thing, if you've ever been to Penn State main campus, there's one of these outside of the Walker Building. The meteorology department is actually part of the co-op network, and it's actually a student's job every day at 7 a.m. to go out and take that measurement. So on the other side of this slide, we have the citizen scientist networks. Citizen scientists make a huge contribution to rainfall measurement just by offering their own equipment and their own measurements. So this relieves the official networks from having to install more of these, I guess, higher tech equipment, which unfortunately that comes out of our tax dollars. But these networks would be the Community Collaborative Rain, Hail, and Snow Network, also known as COCO-ROS. There's also the Weather Underground map and also the World Meteorological Organization. And this is just people of various trainings and backgrounds and interests, just reporting from their own stations and contributing to the science, which is a really great thing if you think about it. So now I want to provide you with some information on some previous studies that I found during my literature review that I think are pretty applicable. The first article is from Medlin in 2006. This was a National Weather Service affiliate that was studying Hurricane Danny in 1997, which made landfall on the coast of Alabama. And he was comparing the difference between the rain gauge measurements and the radar-derived rainfall measurements in the landfall zone. And he found that the radar-derived estimates were actually 8 inches more than what the co-op gauge recorded. And they were also in different locations of the landfall zone. So this image here is actually figure 3 from the paper, if you're interested in checking it out. The colors represent rainfall in millimeters as derived by the radar. They were using the tropical rainfall algorithm at the time. And the white circle is where the radar measured the max rainfall in the landfall zone. But to the east of it was where the gauge was on Dauphin Island. So it's in generally the same area, but still not in the same location. So Medlin just suggests that more studies do need to be done on these differences, especially in a tropical environment. The second study I wanted to talk about is from Skinner in 2009, and he was affiliated with the South Florida Water Management District. So they had a goal of augmenting their current rain gauge data network using radar-derived data. However, they were finding that radar products held, call them specific biases. An example is that they underestimated convective events like thunderstorms, which in Florida you get a lot of. So they decided that if they did merge these methods, they could have a pro of increasing their spatial representation of data, but they did have to do more work to quantify these biases before the merger could happen. And these figures here, on the left is figure 5 from the paper. They plotted the rain gauge measurements in inches versus the NexRad measurements in inches. And as you can see, they're not a one-to-one comparison. They had to do a little bit of forcing in there. In figure 6 on the right from the paper, they were plotting the kind of rainfall ranges. They bin them in inches versus the relative frequency, or how much that each type of method was taking it. So the black bars are the rain gauge measurements, the gray bars are the NexRad measurements. So I think it's interesting, the radar is seeing more of the middle kind of rainfall amounts, and the rain gauges were measuring more on the extremes of the rainfall amounts. So my last piece of background that I wanted to mention is the storm that I'm going to be using as a case study for this project, and it's the recent Hurricane Idalia. So Idalia made landfall on the morning of Wednesday, August 30th, 2023, in the upper bend of Florida's Gulf Coast. When it made landfall, it was a Category 3 hurricane, so it had sustained winds of approximately 125 miles per hour. The storm itself was about 355 miles or 575 kilometers in diameter, and the image here is the visible satellite. And it was bringing storm surges that were over 5 feet all along the Florida Gulf Coast. So the goals of this project are driven by the acknowledgement that there are differences in rainfall amounts measured by these different methods and networks. So I'm essentially questioning what the magnitude of that difference is and what is the cause. So along those lines, we want to quantify these differences between the measurement networks, perhaps derive some sort of an equation to model this exact difference that we could potentially apply to other storm events. We would also want to just have a discussion about the potential sources of these biases. An example that I can think of is maybe there's a lack of citizen science weather station gauges in one particular area, so it's relying more heavily on the radar. So the gauges are not going to perform as well. So that could be a socioeconomic problem that we may be able to fix. We also want to garner a quantitative and qualitative understanding on how these observations can be integrated into other products to make them better. An example, if we did have that equation to model the difference, that would definitely help in terms of initiating the numerical weather prediction models that I mentioned earlier. And just a personal goal, my undergraduate was in meteorology and atmospheric science. So as I've been pursuing the master's in GIS, I was always kind of looking for areas that I could merge the two disciplines. So I felt that the capstone project was a great opportunity. So love looking at rainfall measurements. Okay, so moving on, I wanted to show you the exact study area that I'll be using to clip the data and whatnot. It's this graphic I created in the blue rectangles, the exact area. It's approximately 3,400 square miles. It is the greater Tampa Bay area on Florida's Gulf Coast. So it does include the cities of Tampa, Clearwater, and St. Petersburg. The reason why I chose this area in particular versus other parts of the Florida coast is that this area had a very nice variety and amount of data available. And it was moderately to highly affected by both Idalia's rain and winds. So this area was having rain from very early morning, August 30th, to the very early morning of September 1st. So now I want to give you some information on the data sources that are going to be used. This project is very data heavy. The first source is the Applied Climate Information System, or ACIS. So this is actually a collection of many of the networks and sources that we've already discussed, like the National Weather Co-op, COCOROS, the WMO. It also includes the Weather Bureau, Army, Navy, the International Civil Aviation Organization, and the Global Historical Climatology Network. And each of these networks do have their own rules, so there's a lot of documentation on it that I have to make sure I have straight. But this data can all be downloaded from the link that I have here as a CSV file. And I'm planning on using a Python script to further filter the data to get it in a usable format. The second point source data is from those ASOS stations that I showed you an image of earlier. They are officially maintained between the FAA, DoD, and NWS. They're located on airfields and they do take measurements every 5 minutes, so it is a lot of data. But they are accessed from the NOAA website as a CSV. And again, you can do more filtering with a Python script. To give you kind of a spatial overview of what these points look like, the white points in the map on the bottom right-hand corner represent the ACIS points, and the red squares are the ASOS stations. So there's about 10 ASOS stations in the area and about 82 ACIS points in the area. The last point data is the Weather Underground personal weather stations. That's an image of what one may look like. So take a peek in your neighbor's yard. If they have one of these and they're reporting to one of these networks, you could be getting some pretty good hyperlocal weather data if you're interested. So again, they're just people that are offering their own measurements, and you can access it straight from the Weather Underground website via an API and a Python script. Next, I'm going to talk about the raster data sources that I'll be using. The first one is the multi-radar, multi-sensor quantitative precipitation estimates, or the MRMS QPE. And this is a cool product developed between the Oklahoma University and NOAA National Severe Storms Laboratory. This output would look like the image on the right here. And this integrates weather, radar data, numerical weather prediction models, and surface observations to estimate a rainfall amount. So it actually works as like a reanalysis after the storm event. You can access it straight from weather.gov as a GeoTIFF. The last data source that I'll be taking advantage of is the parameter elevation regressions on independent slopes model. That's also known as PRISM, and they're a group from the Oregon State University. And they experiment with many different modeling techniques in order to create a smooth surface of rainfall amounts. So it would look similar to the MRMS output. And this data can be downloaded from PRISM's website as rasters. So just to give you a brief overview, roadmap of my methodology. First, we'll be beginning by downloading the data in a usable format and for the proper date range. So as a reminder, that's going to be August 30th through September 1st, just to encompass all of the days that the Tampa Bay area was getting rainfall from Idalia. Next, it's probably going to be the most amount of work is the data preprocessing. So this is going to include syncing the times of each data source that I outlined, defining the reference system in each of those sources, clipping the data, and then removing any outliers caused by faulty instruments, particularly in the point data sets. Then will be a fun part is starting with some exploratory analysis. So that's just plotting the data, getting it into ArcPro, setting up the symbology so that it looks logical, and also experimenting with different ways on how to create raster surfaces from the point data, because that's how I'm going to base the analysis. I do know the inverse distant weighting function does work, but I want to try a few more ways to see the best data that I can get. Next, I'll be running some statistical analyses to reveal relationships between the data. I anticipate this being kind of an iterative process. I can't be exactly sure what test I want to be running until I can see the data, so I may need to alternate between plotting and trying tests. I've considered leveraging functional data analysis and simple deviation, but again, I want to do more research first after I see the data. But this portion will most likely be done in RStudio. But once I'm pleased with the statistical output, I want to finalize the rest of the results. I do want to include a visual result of a heat map to show the magnitude of the differences between the measurement methods. So I did want to take some time and point out a potential challenge that I think I'll be facing. I mentioned that time syncing is going to be a large part of the data pre-processing. The result of this process is also going to kind of steer the analysis in terms of the time interval that I'll be using. So as an example, we know Coco Ross and the co-op data is taken 7 a.m. daily, but the ASOS station do record every 5 minutes. So there'll be some translating to do there. Further examples, I know some of the data sources record in UTC time, and some of them record in local time, and that's not always clearly documented. So it may be difficult to get them all lined up exactly to be a daily analysis, which is what I'd be hoping to do. If all else fails and I can't get them to line up the correct way, I'll stick to a storm total analysis. So just the total for over approximately the 2 days that they were receiving rain. Okay, so here's just kind of a basic timeline that I'm proposing. It's decently loose. I'm planning on taking 596B in the summer of 2024. So I'm aiming to do a presentation at the beginning of June. Due to the challenges that I just showed to you on the last slide with the data pre-processing, I gave myself a significant amount of time to accomplish that. So essentially from like right now until mid-February, just working on the data stuff. And then besides that, most of the analysis work will be done throughout the late winter and spring seasons. So just giving a couple ideas on potential presentation venues, Dr. Savona and I decided that this presentation would be appropriate in an academic setting. So based on some preliminary results that I will get down the road, we will start to organize with the geography groups at either University of Delaware, Columbia University, or Rutgers University. They're all semi-local to me, to see if I can come and present my work there. Since this is a focused case study, I would love to see some of their students and affiliates get excited with this problem and try to expand upon my results, perhaps by looking in other areas, using different data sources, or even different storm events. So to wrap up, just a quick note on my anticipated results. I'm thinking I will be confirming that the radar-derived products will measure more rainfall than the rain gauges for the majority of the study area. That's kind of in line what Medlin and Skinner were seeing in the tropical environments with convective storms. I'm also anticipating generating an equation/model to relate all of these data sources together or to quantify their differences. And lastly, I want to provide just new knowledge on how this data can be used in other applications, even with their associated biases. You know, we have a lot of data. We want to encourage citizen science, so we want to be able to use it. An example I keep going back to is the numerical weather prediction, because they do start with surface observations before they let the computer go ahead and create the model itself. The saying here is garbage in, garbage out. So if there is a strong bias with one of these things, we still want to use it, but we just may need to temper it a little bit. So yeah, I'm excited to see how this comes out. This is all I have for you. If you're interested in references or image sources, please let me know, but I will now take questions.
All right, thanks a lot, Christina. That was a really good presentation. While we wait for questions in the chat, I'll kind of start things off here. Under your challenges, you mentioned about the timing issue. Another challenge you may want to consider is your point distribution with the stations. The white dots seem to have a pretty, I guess, more expansive coverage of your study area than what the red dots do. And I'm not sure about the personal weather observations and where they're located. And I bring this up from a standpoint that, because you mentioned something about the spatial interpolation, ID inverse distance weighted as a a tool that you're going to use. So the distribution of the points and the success of the spatial interpolation is going to matter. So I think that's something that potentially could be addressed. And then kind of following on that is that, with any study boundary, if you're doing a spatial interpolation, the edge effects, sampling points immediately outside that boundary so that the boundary itself has a good representation of what your data are. So you may want to extend your sampling to points that are, I don't know, a couple miles outside your defined boundary so that the edge effect could be potentially minimized.
Okay, yeah, I will take that into account. Thank you. I do have a message from Beth. She says the information about measurement instruments and reporting networks was eye-opening. I've walked past that old equipment at Walker for years and years and had no idea how state-of-the-art it is. I'm glad you're able to combine your undergrad and grad work for the project. Are you currently doing work in a meteorology or GIS related fields? I'm actually working in transportation as a GIS analyst. So not quite meteorology. Hopefully down the road can get back into it. But yeah, GIS with transportation work.
Any other questions for Christina?
Looks like we have one from Jim. You talked about issues with observation data. Are you approaching this from the standpoint of the observational data being more correct than the radar derived, or just modeling the difference between the two? Yes, this is an interesting point. We kind of discussed this in detail between me and Guido. It's hard to say which one is correct because we just don't know, because there is inherent issues with each of those methods outlined. So I think we're going to take the National Weather Service co-ops and ASOS as kind of the correct ones. And they're going to act as the baseline to model the differences, if that makes sense. It's not an easy question to address, but that's kind of the scheme that we're going to follow.
All right, well, Christina, if you could put your contact information in the chat so that if anyone wants to follow up, that'd be great. And thanks again for your presentation.
Okay, thank you.
Next up, we have Stephen Douglas. If you want to go ahead and start sharing your screen. Are you on, Stephen?
It's possible he stepped away since we're a little ahead of schedule. Let me reach out to him real quick. I
Okay.
see him in the chat, or in the room, but
Yeah.
I'll reach out.
Okay, thanks. Oh, Stephen, if you want to go ahead and start sharing your screen, we're running a little ahead of schedule. And you're muted, so we can't hear you yet.
How about now? Can you hear me?
Yes. Yep.
Do I put PowerPoint in play mode?
Yes. You want to share your screen. Do that first.
You see it?
It's yes, we do now. Yes, and now you can go ahead and hit play, and that should take care of it.
Sounds good. let me just say, before I begin that I'm getting over a major cold. And if the frog in my throat comes out a little too much, just let me know and I'll speak up. But I took some cough syrup, I got my honey water, and I'm ready to go.
All right, that sounds good. Well, we hear you okay now, so you should be in good shape.
All right. Well, the title is Spatial Temporal Analysis as Warning Intelligence, examining the Hamas attack on October 7th, 2023. First of all, some definitions, important to get these down because I use them throughout. A warning is a notification of impending activities that may or may be perceived to adversely affect U.S. national security interests or military forces. Warning intelligence is a product on which to base that warning. Intelligence involves the identification or forecasting of events that would have a sudden and detrimental impact or effect on U.S. foreign policy concerns, and spatial temporal events represent discrete happenings occurring in continuous time. As an introduction, let me just start that I've been looking at this region for a long time. I've actually written on it in different courses in different ways. But after the events of October 7th, our focus changed. And how it changed will become clear if you'll just bear with me. We expect the spatial and temporal sequences of munitions to follow some predictable pattern. But sometimes the temporal pattern is interrupted by unexpected absences or occurrences of events. These anomalies need to be identified and may serve as an indicator. A quick and convincing identification and explanation of these anomalies are an essential part of warning intelligence. The purpose here is to examine the long-term spatial and temporal patterns of Hamas firing indirect munitions into Israel. So I'm looking at space and time. My motivation is to determine if examining the spatial temporal pattern might have provided Israel with a quick and reliable source of warning intelligence prior to the events of October 7th. The goal is using the Hamas attack on Israel as a case to determine if common spatial temporal analytic methods in ArcGIS Pro could have provided warning intelligence prior to the events of October 7th. Let me stress these are common spatial temporal analytic methods in ArcGIS Pro. Quick statement of the problem. Were previous Hamas indirect fires an indicator of where and when the attack on October 7th might occur? I'm looking at where and when. And here's a quick rundown of the arsenal that Hamas has. I'm focusing on rockets and mortars. These are not all of them, but they're most of them. It just shows the name and the range of each. As a matter of fact, just kind of interesting, in the news just last week, they hit a northern part of Israel using the AH-250, and that was over 200 kilometers. That's the longest range shot yet. Reportedly, it was intercepted by Israel using their David sling. But their favorite munition of choice for many years now has been the Qassam, and as well as mortars. It's their shorter range munition. And also in the news recently, as that last bullet shows, they've used mortars and artillery on October 7th. Some of these were from North Korea. Some of these were from Iran, of course. Many of these were made in Iran. And just kind of interesting as a side note, there was a video of one combatant, we'll call him a Hamas combatant, with an M16 from the US. And right now the senators are wondering where he got that. So they're looking into that. So more on this. Here's a picture of the different missiles that they hold. They hold more than this, actually. But as you can see, the range goes up to 250, and they have the 107 millimeter rockets. That's the smallest rocket pictured here. And of course, it shows what they have, but not how many, and that is a different question. Many of these they produce indigenously. There's videos of them digging them up. They keep them under the ground. Then they put them together, pour in the explosives, and fire them off. They also use some of these that have been used by the PIJ as well. The Qassams and the Badr, for example, are pictured here. They've used those as well. The Fajr 5 in the lower left has been used to strike Tel Aviv with a 75-kilometer range. So they have a lot. All right, deliverables. A spatial temporal analysis of Hamas munitions fired into Israel for the period of January 1st, 16th to October 7th, 23. And let me just say, I cut it off at October 7th. The reason is after that, it would skew my findings. So that's where I cut it off. Secondly, a map of Hamas targets on October 7th. And finally, a spatial and temporal analysis of Hamas indirect munitions fired into Israel, providing actionable warning to the events prior to October 7th. There are several assumptions, of course. ACLA data is your armed conflict location and event data. That's what I'm using. The assumption is it's sufficiently complete and correct, relying on that. And let me just say that a lot of that data comes from the news. The source is listed there, the news sources. Secondly, Hamas attack on Israel on October 7th was planned prior, at least 2 years as it's reported. The planning, including deception of the event and timing, and perhaps I might be able to show some of that deception in the sense of how they fired their rockets, when and where. And also Hamas attacked their intended targets. The targets they attacked were those intended. Now this is a hypothesis matrix. Looks complex, but it really isn't. Conceptually, it shows you there's 4 hypotheses. On one axis, we have a temporal pattern. On another, we have a spatial pattern. And they vary from insignificant to significant. So you can have a significant spatial pattern and an insignificant temporal pattern. You can have insignificant spatial pattern and significant temporal pattern. You can also have both significant or both insignificant. So conceptually, these are my 4 hypotheses. And on the next slide, I'll spell them out for you. First of all, there were significant spatial and temporal patterns which provided actionable warning intelligence prior to October 7th. Or there were no significant spatial patterns, but there were significant temporal patterns prior to October 7th. Or there were no significant temporal patterns, but there were significant spatial patterns. Or finally, there were no significant spatial or temporal patterns prior to October 7th, 2023. And yes, I'll be using analysis of competing hypotheses to evaluate these. All right, now just a quick look at my workflow, assuming I guess it starts next semester, of course. That will be in January. I'll start by plotting and graphing the data, if not before that date. I'll apply spatial temporal tools after that. I'll test the hypotheses using ACH as mentioned. Then I'll reevaluate those hypotheses and then retest them. The reason that's important is because with ACH, the hypotheses can change. You can also perhaps have new hypotheses. And then I'll arrive at the findings later on and complete the report, which is due, I believe, in March. That's when it ends anyways. Methodology. The evidence will be primarily quantitative regarding the number, location, and date of rocket impacts in specific areas over time. The analysis will be qualitative also regarding how the pattern of attacks differs over time and geography. I'll conduct hotspot and density analysis. I'll also utilize binning to be used for statistical analysis. As you know, with density analysis, you can have a nice picture, and it's sometimes very effective, but it can vary depending on the symbology you use. But binning, on the other hand, gives you raw numbers that you can work with, and it's a lot more better for statistical analysis. Time series analysis forecasting using ArcGIS Pro, including the space-time cube and forecasting. And of course, graphs and other visual methods will be used to illustrate the findings. All right, now I just have a couple slides that illustrate, a few slides that illustrate evidence of what I'll be producing. Hamas tactical objectives. They called it the Operation Al-Aqsa Flood. And I'm sure you're aware they cut through the fence in Gaza, infiltrated at least 7 or more areas through the fence. And their tactical objective apparently was to infiltrate, kill, and capture. And this occurred on the end of a major Jewish holiday as well. And this pictures the, this is where they infiltrated these towns as located with the red symbols here. Mission impacts and tactical objectives. This basically shows every place they've struck from January 1st, 2016 through October 7th. It's a bit deceptive because they've struck several of these more than once. But I'm just showing this as illustrative to show, for one thing, they've struck these same places they've infiltrated on October 7th. And I'll be looking into that further as far as when they did that and how often. And as I said, I'll be concentrating on periods before October 7th because otherwise it would skew my findings. And many of the impacts, of course, as I said, were in the same areas. Looking at clustering, you can see that the majority of attacks were in the Gaza area. It's been reported that the Qassam rocket, which is the shortest range rocket, is their weapon of choice. They've been using it for a long time, along with mortars. And that goes in the closest range right over Gaza, and that's where most of the attacks occurred. Over this period, there's been 842 total explosions. And I'll be examining different regions over different time periods. It's important to stress that. And finally, this is a quick bibliography of my sources. And I'm open for any questions at this time.
Okay, thanks, Stephen, for your presentation. While we're waiting for questions from the audience, oh, it looks like you have a question right now. So, Stephen, if you open up the chat window, you should be able to see the question.
Oh, I don't have that open.
You go down to the bottom, there should be a chat icon that you can click on. Maybe under the more option with 3 little ellipse dots.
Okay, I got it. Was this from David Jimenez?
Yes. So if you could read the question first before you answer so we can record the question.
Hi, Stephen. Wonderful view of the events leading up to October 7th. Quick question. In your opinion, do you think the launching of various rockets fired by Hamas were in close proximity to their underground tunnels? I'm an adjunct with Dr. Bakastow and Dr. Thomas. I honestly don't know. I do not have the data that shows where the underground tunnels existed. I do know, I can tell you this, that it's been a battle for some time. It's well known that they do have these tunnels. And I believe there was several operations in the past in the open press that reported where they blown up some of them. But you know, to directly answer your question, I do not have the data showing where these tunnels are. So I can't really answer that honestly. Let's see, I think there's more coming in. Here's a question from Dr. Thomas. Have you queried and downloaded any ACLA data to see if it is sufficient? The data may need to be resolved and cleaned. I have downloaded it and I have looked at it closely. I've used it before. It does appear to be very sufficient. How good it is as far as how accurate it is another question. And that's one of my assumptions that I rely upon. Just for your information, I did at one time, I gotta be careful what I say, but I was working on a project a while ago for another place, another country that utilized data from the Jane's database. And I used that along with ACLED just to fill in the gaps. So ACLED data is good, but it's not complete, I would say, you know, because Jane's is pretty good as well. But I think we'll get a pretty good picture of what was fired. You know, might be 99% complete. I can't say exactly, but this is unclassified and that's what I'm relying upon. I do think it's good data though.
So Steve, one question for me. So what is your long-term goal with this project? I mean, who would potentially benefit from your conclusions with this project?
That's a great question. I actually had that in the brief at one time. I think anybody who works in the security establishment would be interested if I do reach a finding. You know, this is one of these kind of things that I may find there was no correlation. I may find there was no deception. You know, maybe they weren't that smart. But if I do find a correlation with where and when they attacked to the, where and when these explosions occurred to the attack on October 7th, that would be useful to security people, defense people. It'd also be useful to tourists as well. Now, I've read that Israel has a system where they sign the alarms go off if a rocket is impending. They may not have a lot of time to go to the bomb shelter, but they will give them some sort of advance notice. So, but this is something that if I do reach findings, would be helpful certainly to those who warn others in Israel, because it shows patterns in how Hamas works. It's a warning or an indicator that an attack is impending. I hope that answers your question.
Yes, thank you. If you could put your contact info in the chat window and
Sure.
There's one more question from Jim, Fritz.
Oh, sorry, didn't see that. Stephen, there's one more question for you.
Yeah, one more question is, did you consider trying to incorporate other types of attack beyond rockets? I did. They have a lot of other munitions, for example, anti-tank weapons and other kind of weapons. That would just expand the scope a little bit too difficult to grab a hold of. I'm painting myself a box here, a sort of box from which I analyze, and that's that's my focus. And if I find something here, great. If not, so be it. But I have a lot of data on the attacks from rockets. In the past, they used other things like the first intifada, second intifada. First one was, I think it started around the 80s, 89. And they had a lot of suicide bombers. They've used a lot of things in the past. But I have a lot of good data on rockets being fired, as well as mortars. So utilizing that good data, I hope to make a finding. The other types of munitions they've used are much more scattered and infrequent. So having this rocket data allows me to conduct this analysis where I can come to a good conclusion, some kind of conclusion, instead of the others, which is a little more scattered and just less of it. Okay, he says, understood. Quick follow-up. This is certainly a timely topic. Yes, it is. Were you already thinking of analyzing Hamas rocket attacks, or did you make a late topic switch? Great question. I have analyzed rocket attacks before in a couple of classes. In fact, as in one of your classes, I developed an application where we looked at, an individual could actually place the spot where they viewed somebody launching a rocket. And this would be a field application. In one of your classes, I did that. But to answer your question more directly, I have been looking at it for a long time. And but once again, after October 7th, my focus changed. I think this is a unique opportunity to look at patterns in time and place and see if that's an indicator of whether an attack can occur in the future. So I shifted my focus at that time. Okay.
Any other questions for Stephen? All right, Stephen, if you could place your email in the chat and stop sharing your screen so we can get the other presenter going, that'd be great. All right, thanks.
Thank you.
Our last presenter for the day is Sean Mack. Sean, if you want to start sharing your screen, we'll check, make sure that works.
Yeah.
All right, we see your presentation. So whenever you're ready, you can go ahead and start.
Okay, sounds good. Well, thank you, Stephen. Before I start, it sounds like that kind of research can be very impactful. So I appreciate seeing that. But yeah, my name is Sean Mack. I'm an archaeologist working mainly in Alaska. I got a master's degree in anthropology back in the mid-2000s. And as part of that master's degree, I also did they called it a post-baccalaureate GIS certificate. And so I've always been kind of interested in utilizing GIS in archaeology, specifically in Alaska. And when I found out about the MGIS program at Penn State, it seemed like a pretty good fit. So that's kind of where this started from. But in this presentation, I'm going to go through a little bit of why I want to use automated detection to find archaeological sites, and how it kind of can be used specifically in Alaska because of Alaska's unique archaeology and unique geography. So to start with, for those of you that aren't familiar with Alaska, it's really big. It's by land area, it's about a third the size of the continental United States. It's got more coastline than the entire lower 48 combined. And I always like to joke around with people from Texas because they generally like to think that Texas is big. And I say, well, if because Alaska is the biggest state and Texas is the second, if you split Alaska in half, Texas would become the third largest state because both halves of Alaska would still be bigger. So field work in Alaska can also be difficult because infrastructure wise, well, it's such a huge state, we have about the same amount of roads as the state of New Hampshire. So if you think of the roads of New Hampshire spread out over the entire eastern seaboard, you get an idea of how large Alaska is and how expensive it can be to travel. Alaska also has 229 federally recognized tribes, and the way Alaska's geography and travel work, because there's so little infrastructure, is that you generally have one or two major population centers like Anchorage, Fairbanks, Juneau, and then within each of these cultural regions, which are almost like individual states, you have hub villages. So often you'll travel from a large population center like Anchorage to a hub village. From one of those hub villages, you'll travel to a smaller village. And if you're looking for an archaeological site near that village, you would take a skiff or a four-wheeler, some sort of ATV to that site. So to get to some of these locations, you have to take a variety of travel methods. So that's one of the reasons why I'm really looking to automate and do as much remotely as possible, because to get a crew of archaeologists to a remote location can be difficult. It can also be a little bit dangerous. This is my obligatory selfie with grizzly bears coming down the trail. And realistically, the danger is not too great, but it can be dangerous to go out that remotely, especially when you're so far from the nearest hospital. So next, I'd like to talk about what archaeological sites in Alaska look like. Alaska is somewhat unique in how archaeological sites look because of the unique climates. A lot of people created these semi-subterranean houses where you would dig down into the sod, put a frame around, and then fill the top with sod. Very insulated, very wind resistant. So it was really really unique. Some of the drawings at contact would look like this, where you have a mound. In this case, these are Unungan or Aleut villages, in which the entrance to the house would actually be in the center through the top of the house, something like this. In other areas of Alaska, they would have a different type of house, maybe instead of a tunnel through the top. In colder areas, sometimes they'd have these kind of cold trap side entrances where there would be a dip before you got into the main structure. In the Aleutians, it didn't get that cold, so the entrance through the top worked all right. I think this is a sketch from one of the Captain Cook. I think it was 1803, where he came through the Aleutian Islands and stopped at the island of Unalaska. You can just see, so this actually isn't Alaska. This is Point du Hoc, Normandy, one of the D-Day battles, and this kind of shows the landscape after naval bombardment. And this is actually what archaeological sites look like in Alaska. When those semi-subterranean houses collapse, they create these, the best way to describe them is bomb craters. And so this is very similar to what you would find if you were walking through an Alaskan archaeological site. An aerial aerial photo, just as I was flying by in an airplane, kind of shows that style. It's pretty difficult to travel out there during this time of year, especially remotely, because you never know if you'll get stuck or not. So this might be the best time to do survey because you can still see some snow in the individual site features. But it's very difficult to get out there this time of year. Generally, you have to go in the summer. But when you go in the summer, the vegetation can be very dense, so it gets difficult. This is the last time that site was visited was the mid-90s, and this is the map kind of hand-drawn. I think they edited in Adobe Illustrator, and it's based on what you see. It's based on what you see on the ground. But during the summer, the vegetation in Alaska gets so dense, it can sometimes be pretty tough to see site features on the ground when you're hiking through 5-foot tall grass. So this all kind of goes into why I'm so interested in doing automated identification and how studying elevation of sites can really help map those site features. This isn't an archaeological site with site features, but it is a culturally important area. And before we flew out there, the topo map on the lower left was almost the highest resolution. It was the last time it was really mapped. There was some satellite imagery on Google Earth, but it wasn't very great resolution. I just went out there with a drone when we traveled. I said, well, let me bring the drone and maybe I can take some aerial images and you can share them with the tribe. And with those aerial images, using photogrammetry, I created this digital elevation model, which is great, especially if I wanted to know specific information like which ridge is taller and how many more meters high is one side than the other. But unless you're trained in how to read either a topo map or a DEM, the use of things like a 3D model can be really important, especially for younger kids, because that's the way your mind works. Your brain sees immediate connections in a 3D model that it doesn't immediately see unless you've been trained on how to read some of these other map types. And so to collect that data, I would use the drone and essentially run transects and use a program such as Metashape to do the photogrammetry and stitch those together. Another application of this is in a place called Ugashik. This is Google Earth, just zooming in, and you can actually see archaeological site features from Google Earth in some locations. Here you'll see the different vegetation type, the light areas, you can start to see individual features. So that's an archaeological site in Alaska that you can find using remote sensing. In fact, you can probably see it better than the aerial imagery here because of the contrast. But what you can't see without looking at the aerial imagery is really the high definition. In this instance, you can zoom in to my coworker in a site feature and count the squares on her plaid shirt, whereas Google Earth is just a blur. So even though the Google Earth image, you can see the site, you can't really do much analysis like you could with the aerial imagery and stitching it together into a DEM. You can kind of isolate that into the actual site, and you can see these lower areas of elevation surrounded by berms. You can also see game trails, and in the bottom of the screen, you can see the helicopter that we had to take to get there. So this was the analysis I did based on the aerial imagery. When we were out in the field, we actually mapped the site features with a Trimble, and what we saw in the site that we mapped was the exact same as what we were able to see in the aerial imagery. So if with the exception of one area where a game trail bisected and we didn't think that it was a cultural feature, but looking in the DEM, we thought it might be. And we did see one other depression that may or may not have been cultural that we mapped further north. But basically, if I would have gone out there at some point, if there was going to be research done on this site and excavations, I could have gone out there with a drone one day, done a fair amount of office work when I got back, and the next crew that would go out there for excavations would have a really good data set to decide how they wanted to excavate the site before ever having to get there. So you can save time and money by using this technique. The question for me, though, was that works great for an individual site, but what if I want to do a whole river? You know, if I was out there with a drone trying to get elevation data for an entire river, it would take me months or years. Well, there was a tribe in Alaska from the village of Igiugig that got LiDAR data for a large portion of the a river, the Queechak River, which runs from Lake Iliamna down to Bristol Bay. And I'm sure a lot of you have probably seen LiDAR being used in Central America to you know, see through vegetation, to get a bare earth surface and be able to see individual site features under vegetation cover. And so, you know, my idea was, well, if they can see individual site features through jungle canopy, hopefully, you know, LiDAR might be able to help us see bare earth site features in this type of vegetation. So we could create a ground surface such as this, even in the middle of summer. But the question, I guess, was how to go from this, a DEM of a site, apply it to Igiugig, and you know, how do we manipulate the LiDAR data in ArcGIS to find those site features and create a DEM that we can use to automatically look for them? So I thought, why not use a hydrology tool called, you know, FillSync? And basically, for those not familiar, this keeps a continuous flow path so that you can study the flow and direction of rivers and streams. It's a method to fill in generally incorrect data so that it doesn't create basins that would stop the flow. So generally, this tool is used in hydrology, and they're interested in the line with arrows, whereas I'm interested in the actual sink, because that's what the archaeological site features look like. Other way, this is in LP 360, but this is an archaeological site feature, and I just wanted to show you can see this berm, and you can see the sink that I'm trying to find in the bottom there. So this is a DEM from the LiDAR data of an archaeological site. You can see two things here. One is a pixel that say is 5 meters above sea level. The other is 10 meters above sea level. Well, when you fill that sink, the pixel in the middle of that feature becomes 20 meters above sea level, whereas the pixel that was off is still at 5, that was not filled. So if you take a simple raster calculator and subtract it, you get this kind of image where you see all of these sinks. In every place where a sink wasn't filled, the value of the pixel doesn't change, and it results a value of 0 when you delete it. Well, this is kind of way too noisy to actually look at what would be a site feature and what wouldn't. And one of the reasons is because a lot of times the land is hummocky. You have all these almost micro sinks that fill up the map and make it difficult to decipher. And I should say, when this project started, when I thought of this process, I thought it was pretty unique. When I started looking at some of the research that had been previously done, it's a very similar technique to something that they use in Central America and Florida to detect sinkholes. But my understanding is that area is fairly flat. They don't have the hummocks. And so I kind of have to continue that analysis a little bit further. And if it's going to automatically detect site features, there's more analysis that'll need to be done. So it's an interesting technique that can be used for multiple disciplines. So when I start with this and I want to delete all those, I just kind of say, okay, oh, I'm sorry, this is somehow got recorded, but the way that I isolate it is basically say, let me take all of the depressions deeper than 1 foot, all of the sinks that have a maximum depth of less than 1 foot, or of more than 1 foot, are most likely cultural, and all of the sinks that are less are most likely natural. And what you end up getting is a pretty nice map of these site features. This is kind of the model builder flow of how to get that data into a end result that just shows archaeological site features with attribute data such as the maximum depth or average depth. And this is a fairly involved process. And if you don't know GIS very well, it can be pretty confusing. So ultimately, I would like to create a tool that does this automatically, and so that an archaeologist in Alaska that has LiDAR data can simply point to where that data is located on their computer, hit run, and it'll go through this process and leave them with a polygon feature of the site features with some attribute data associated with it. So taking that methodology with the data set over the entire river, running it through the model, this is kind of the timeline that I am looking at in order to finish up the project. So I've already got the data. The testing of the methodology has been ongoing. I'm still refining it before I start scripting the tool, but I would like to expand it to the larger study area during the 596B course, and I'm hoping to have the tool done by early February, because I would like to present at the Alaskan Anthropological Association meeting in February of 2024. And my goal would be to show up at that meeting, give a presentation similar to this, but have final results, and also be able to present a tool that anybody else can use, even if they don't have a ton of GIS experience. So this is what a final image looks like on one of the LiDAR tiles. The site that I had shown earlier is in the top right of the screen, and you can see two additional sites in the bottom left. There is one or two features in the bottom right that are more inland, that are probably natural, and a couple of the polygon features in the top left of that image are probably natural, because that's a low-laying sandbar that was recently formed, and I don't believe would have cultural features. So there's still a little bit more refining to do, but you can see hopefully the potential it has, and if I can run this over the entire data set, documenting sites, mapping site features remotely before ever having to visit the property can be very, very exciting for Alaskan archaeology, that it'll save money, time, and we'll be able to look at larger geographical areas. So, yeah, any questions?
All right, thanks, Sean. That's a really intriguing project you're working on. A lot of unknowns, I guess, from the standpoint of, you're looking back in history and you really don't have much of that history recorded,
Right.
Especially in terms of where people lived. I assume they were rather nomadic in their living arrangement.
Yeah, it kind of depends on the location and the culture and the time. In a lot of places in Alaska, there were large permanent villages, especially at the mouths of salmon streams, coastal areas. In the interior, a lot of times there would be nomadic movement. Tribes would move from the coast to the interior, depending on the species that they were targeting, whether it be caribou or sea mammals. So there's variation in terms of how the cultural entities moved and lived, but yeah.
One bit of evidence I think would be very helpful to you to consider further is the fact that the buildings tended to cluster together, right? They weren't necessarily sort of isolated houses, or I'm sure what not sure what wording to use there, but so there was a cluster of these domiciles instead of singular ones, and that may be a way to help identify which of these locations would deserve more attention. And looking back through historical maps, you could find evidence of things like sandbars or other barrier islands that perhaps were inundated and were simply not feasible for habitation.
Yeah, definitely. There's the cluster analysis would definitely be useful. Historic maps are sometimes difficult to come by, especially pre 1850s. 1867 is when Alaska purchased, or the U.S. purchased Alaska from Russia, and I don't know of a whole lot of historic maps prior to that time, but it's still a resource. So, yeah.
It looks like you have a couple of questions in the chat window.
Oh yeah. So first question from Christina. I may have misheard, but did you say you were using Trimble equipment to survey some of the sites? Yeah, so we would use Trimble. We had a Trimble Geo XH, and typically we would go to a site to survey it and use the Trimble XH to walk around the site features to draw polygons, and then generally either a line or a polygon to represent what we determined was the site area. And then once, if we were going to make a map for like a publication or a report, we generally take it back to the office and kind of smooth it out and make it a little bit nicer. So yeah, we were using Trimble. Next question. I wonder if you could also include a polygon minimum area criterion into your model in addition to the depth criterion to eliminate polygons that wouldn't be big enough to have in a home. And yeah, I have thought about that, because when I run the raster to polygon to create all of the features, I then have been running zonal statistics on it to find attributes like the maximum depth, and so that I can use that to take away the shallow pits. But it'd be pretty easy to also have the area calculated and do the same type of thing based on like square footage. I haven't done that, but that's definitely something I'll look into.
All right, so any other questions for Sean? Sean, if you want to put your email contact in the chat for anyone who wants to contact you at a later point, that'd be great. And for all of the presenters, I included a link to the peer review forms in the chat window. So if you could take a look at that, go back and review the presentations and provide some peer feedback, that'd be appreciated.
On it looks like
there's one more question.
Yeah.
Oh, sorry.
One more question that says, after you arrive to the areas, how do you determine which are valid? Some of it is subjective. When we get there, looking at the shape of the depression, if it's odd shapen, or if we get there and look at it and we say, well, there's some game trails that go through here, so this depression might have been natural. Generally, if you find an area that has a cluster of depressions, you can be pretty certain that you're in an archaeological site, and that the majority of those depressions are culturally related. We would also generally do test pits, just small testing shovel holes to see the stratigraphy of the site and see if we could isolate charcoal layers that might represent a living surface, or artifacts, if artifacts are present between, say, two volcanic layers. You can kind of say, well, we're pretty sure that this site was occupied between this volcanic eruption and this one. So there's different ways, but basically when you get out there, if you find a cluster of depressions, it's a site, and that's kind of what we go by.
Great. I want to send out a big thanks to all the presenters and everyone who showed up to listen and ask questions. We really appreciate the contribution and participation. So that wraps up our presentation for the day. Wish all of our MGIS students best of luck in your 596B pursuits. And Congratulations on reaching this milestone. Hope everyone has a good rest of the day.